Welcome to HP Tuner's Ford Gen 1 Coyote Training Part 10. In this training module, we're going to be taking a look at working with our fuel injector characterization data in our Ford PCM programming. Our fuel injector characterization data is going to be accounting for the flow rate of the injectors that we have installed in our fuel system. Also, the characteristic response of those injectors. So as we're commanding them to open and close in the electrical circuit, how that response can be programmed into the Ford PCM so that when we're commanding a certain amount of requested fuel mass, it can translate that into an injector pulse width that we actually send to the injector for it to spray fuel into the engine, so it's going to do exactly what we program. So we're going to break down how it all works, also entering in injector data from an injector sheet into our calibration file so that we know how to transfer that information properly. We're going to have a lot to cover. Let's jump in so we can check this out.
Okay, so let's get started. We're going to be taking a look at programming our fuel injector characterization data based on an aftermarket injectors we might be installing into our fuel system for our Gen 1 Ford Coyote applications. We're going to be taking a look at the importance of our injector data and making sure that everything is done properly when we're going from a Excel sheet that's provided from the injector manufacturer, the data sheet, putting all the injector data into the actual calibration tables of where it needs to go. So the first thing I want to do is talk about the basics, the fundamentals of what injector data represents and why it's so important that it's programmed properly. The first thing I want to cover here and talk about is the underlining equation that represents our fuel and airflow model. That's going to be fuel mass is equal to air mass divided by target air fuel. This is probably the most important basic equation that you need to keep in mind when you're doing any calibrating or tuning on your Ford. We'll find that we can measure what the air mass is going to be from our mass airflow sensor. We're typically measuring that in grams per second. Well, we're specifying also what the target air fuel is coming from our target lambda tables. So if we know what the mass airflow is registering in terms of grams per second, and we know what our target lambda is going to be, typically at idle part throttle, let's say, is 1.0 lambda, we can figure out then what we need to deliver in our fuel mass in grams per second. Now, we need to convert the fuel mass into an injector pulse width, and that's what our injector data is going to be used for. It's going to translate to the Ford PCM what your injector size is going to be, also the response time of the injector. So we're going to have a low and a high slope. We're going to have a latency value. We're also going to have a minimum pulse width. All of this data is used into figuring out the conversion from our fuel mass in grams per second into an injector pulse width in milliseconds. We put the incorrect injector data into our Ford PCM, so we don't represent our injectors properly. It doesn't know how to do that conversion properly. And what's going to happen is if we request a certain amount of target lambda, whether it's at idle part throttle or wide open throttle conditions, we'll find that we're going to be running richer or leaner. And we'll find that the short-term correction is probably going to be chasing that rich or lean condition, trying to correct it. And we're going to essentially be introducing an error into the fuel and airflow model. Now, if you don't know how to spot bad injector data and bad trends, if you're putting in injector data supplied and things are off, if you don't know what to look for, it's very easily to go and see those kinds of deviations and try to go and absorb them into your mass airflow curve and essentially skewing up what your reported air mass is going to be. That is going to be a temporary solution, but it's going to start to open up a can of worms. Things like your load calculations all reference what your mass airflow is going to be. Drive-by-wire is going to be referencing your torque calculations. Your torque modeling in your ECU is going to be wrong. It's going to start a chain reaction of creating all kinds of bad data, and it's going to make your car run poorly. So Coyotes are very sensitive to improper injector data, and we need to make sure we're not including that fuel air into our air and fuel model. So the importance of the injector data is very, very high. In fact, it's one of the most important things that we're going to have to set and make sure is accurate. I'm going to have another video on spotting bad injector data, what we can look for and some trends we can take a look at. But for right now, we just need to understand that proper injector data is critical. So whether you're installing Ford Racing performance injectors or injector dynamics injectors, we want to stick to something that has proven data that we know works, that's not going to introduce bad data, that's going to be introducing a fueling error, which will just make your life pretty miserable trying to sort it out. So we always want to start off with an injector that has known data. All right, so now that we've covered the basics of just understanding that we have that fuel mass into an injector pulse width type of conversion going on, let's jump in here and take a look at the tables associated for programming our injector data. We're going to go in here. I have a 2013 Mustang GT stock file I'm going to be opening. Go here to Engine, and I jump in here to Fuel, and I go here into General. we're gonna have an area here called injector control. This is where we program what the injector flows, what the response time of the injector is going to be, and the minimum pulse width that we want to run the injector to before it becomes completely unlinear to try to control. We have our areas here called low and high. This is known as the low slope and the high slope. We also have a breakpoint. The breakpoint is where it transitions from low to high slope, representing what the injectors flow on the low and high slope relationship. We also have our multiplier versus pressure. This is going to be changing what the injectors flow at different pressures. Now, the Coyotes are a returnless system, and they operate between 55 to 58 psi, the way that the fuel system is designed. So they are going to be a relatively fixed fuel flow of the fuel pressure in the system, but the multipliers here are allowing the ability to go in and change what the injectors are going to be based on what the...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.